Welcome friends, and in today's episode we are gonna talk about low copy number DNA or LCN DNA. And this method is commonly used in crime cases and it is executed by forensics. The method of low copy number DNA has a huge problem and we will talk about that later. First of all, what is low copy number DNA? The name itself says low copy number. That means the sample size is extremely small, meaning that we only have a few cells. And these few cells we have only contain a small amount of DNA. And low copy number DNA is a DNA profiling technique which is executed by forensics. And I have a quote here as well. Generally, LCN typing simply can be defined as the analysis of any DNA sample where the results are below the stochastic threshold for reliable interpretation. And this actually says a lot, but we will talk about the problems with LCN later. First of all, we just imagine a crime scene. And the first step on a crime scene is that the police or the scientific police will search small amounts of DNA. And if they find some small amounts of DNA, for example from fingerprints, they have something to work with. So let's say they find a fingerprint. The problem is here, this fingerprint only contains approximately 5 skin cells. And here we are back at the term LCN again, low copy number DNA. So we just have the DNA of 5 skin cells, which is an extremely small amount. So once we have our DNA, usually the next step is the DNA extraction. That is mainly done in the laboratory where the DNA is extracted from the cells. Once we have the DNA, it can be amplified by PCR, polymerase chain reaction. By using primers, a polymerase, and we provide dNTPs, we can duplicate the amount of DNA. A PCR contains many cycles, and after one cycle the amount of DNA is duplicated, and after the next cycle the amount of DNA from the last cycle is duplicated, and so on. So in this example here we have just 2 sets of DNA. But once 35 cycles have passed in this PCR machine, you can see at the number what kind of huge amount of DNA we got after this. So long story short, with PCR we make a huge amount of DNA from just a small sample size. And specifically in LCN DNA, we have a really small sample size and therefore it gets amplified additional cycles, meaning more cycles. Once amplified and we got enough DNA, the DNA can be sequenced or it can be looked for short tandem repeats. But here we are, LCN has a problem. Actually, LCN has several problems and I go through it one by one. So the first problem is that we have only this extremely small amount of DNA. And why is that important or why is that a problem? This is just because of stochastic sampling errors during the PCR, and they can occur. That means if once the amplification of one DNA strand fails, and especially in the first cycles of the PCR, it can lead to allele dropout. And this can then ruin the whole PCR. So LCN is extremely fragile to this PCR method because of the first cycles. There just has to be one mistake in the first cycles and it will continue for the rest of the cycles. The next problem is one of the most common problems with LCN. And this is contaminations. And we provide an example here. So we have this belt on the left side and we see the fingerprint on this belt. And this is evidence or piece of evidence number 1. On the right side we have the knife and this is piece of evidence number 2. So now the scientific police, of course, they wear gloves and they touch the belt and put it away, seal it, and then they go for the knife. But if they don't change their gloves, they will touch the knife as well. And by touching the belt before, the gloves can still contain some small amounts of skin cells, for example, and transfer them to the knife. And the problem here is this knife has never contained the skin cells before. And this is a typical mistake at crime scenes that can happen, even though it should not. So now in the laboratory, by doing LCN, amplifying the DNA from the knife, they can by accident see, oh, we have a piece of DNA here, but actually that never belonged there. So we sum it up again. LCN is especially sensitive to low amounts of DNA. And you can imagine this quite easily. Just say we have just few cells, such a small amount of DNA, and then a contamination occurs. So some other cells from one piece of the evidence made it to the other piece of evidence by unprofessional work. The problem here is that we just have so few cells, and this means that the contamination cannot be covered so easily. In fact, the contamination can actually be the bigger amount of DNA and lead to completely false accuses. So here we have this example. We have the DNA from the piece of evidence from the crime scene, and you can see it in blue. And then by accidentally touching this piece of evidence with contaminating DNA, and we see this in gray, yeah, we have our contaminations, and so the whole PCR is messed up. And I repeat it again, it is especially sensitive when the sample size is small. What is the third problem? And this is also a pretty big problem, to be honest. The method LCN is not reproducible. And when it comes to science, you always have to be able to reproduce your results. But why is it not reproducible? So from nature it's not possible. You start with a small amount of DNA, you amplify this DNA, but after these steps, after these cycles in the PCR, after these amplification steps, you completely lose the original trace DNA in the bunch of amplified DNA. And you can never reproduce since you only got 5 cells. And you don't have 5 more cells to do the same thing again. So after all, as a conclusion, LCN can be a really good and important method. It saved many people's lives. But there are problems and you really have to look where you should use LCN. And I came up with this idea of the video by reading through the evidence of the Amanda Knox case. And Amanda Knox and her boyfriend back then were suspected to be the murderers of Meredith Kerchers just because of wrong pieces of evidence. There were some really messed up forensics and you can actually read it all by your own if you want. I just provided the literature here, so if you're interested in either the case of Meredith Kerchers' murder or in a bad treatment, how a bad treatment of evidence pieces looks like, just go for the links, and I hope this video was helpful. If it was, please give it a like, and I hope we see us next time. Bye.